Here we are with sequences 3.1. So this first one, we're dealing with some exponents. So we've got some exponents here, so 5 to the first. So what does an exponent mean? Well, remember that those exponents is the shortcut way of multiplication. That it's telling us how many times we are multiplying the base, the number on the bottom. So for this one, it would be 5 one time, which would give us 5. Here would be 5 two times, so it would be 5 times 5, which gives us 25. Number 3 would be 5 three times, so 5 times 5 times 5, which would be 25 times 5, which is 125. And then one more, so it would be that, 5 cubed, 5 times 5 times 5 times 5 one more time, or 5 multiplied 4 times. So it would be 25, 125 times 5 would be 625. Okay, now substituting in numbers. Now this is function notation, so all it means is the number on the inside is the input. So we take this function, but everywhere where there's an x, we first put in 1, then 2, then 3. So I get f of 1 equals 3 to the first. And then I don't touch this thing. This is like a variable. I don't touch it. Stands for the output. So 3 to the first is just 3. F of 2 would be 3 squared. So f of 2 would equal, well, 3 squared is 3 times 3, so it's 9. Okay, it tells me an input and an output. So when I input 1, I get 3 as an output. When I input 2, 9 as an output. If I were to graph these, it would be like the x value, the y value. So it would be 1, 3, or 2, 9, and so on. So then the last one, f of 3, so we go f of 3 equals 3 cubed, which is 3 times 3 times 3. So that's 9, so that's 27. So f of 3 equals 27. Okay, number 6, same idea. So I just go f of 1 equals 2 times, instead of x, we put 1 plus 3. And then I just simplify this. F of 1 I don't do anything to. That's just going to be my result. So 1 minus 1 is 0. 2 times 0 is 0. 0 plus 3 gives us 3. So there's our answer. Now f of 2. And then in that place, right, where x is, that's what we're substituting in our number. So 2 minus 1 is 1. 2 times 1 is 2. 2 plus 3 gives us 5. So f of 2 equals 5. Once again, the input and the output. You give me a 2, I give you back a 5 according to this. Okay, now we just do f of 3. So once again, in that x, we put a 3 instead. 3 minus 1 is 2. 2 times 2 is 4. 4 plus 3 gives us 7. And that's our output when our input is 3. Alright, now let's take a look at these tables. So we are going to use this story problem to fill out the table, give an explanation of how we figured it out, then write a recursive and an explicit function. So let's get started. So you run a business making birdhouses. You spend $600 to start your business, and it costs $5 to make each birdhouse. Okay. So if I made one birdhouse, that would be the initial 600 plus 5, so it would be 605. If I made 2, well, 2 birds' houses would be $10, right? 5 plus 5, plus that 600 would be 610. If I made 3, 615. 620 for 4. 625 for 5. 630, 635. Okay, how would we figure out what's going to be in number 8? Well, we're just adding 5, right? So add 5 each time. Now, To help out with the recursive and explicit function, it's a good idea to go back and have, what if I made 0 birdhouses? Well, what would be that starting? Would be just the 600 it cost me, right? That's critical, especially in the explicit, because in the explicit we want to go, and there's two ways we can write it. We can write it y equals, well, where did we start? Well, look at that 0. Wherever you have the input here is 0, that number here is where we start. So we start at 600. What do we do to 600? Well, how is it growing? We're adding each 5 each time we add 1 up here. So it would be plus 5, and then our variable, x. Okay, now I can rearrange that to be y equals 5x plus 600, or I can write it as f of x. We can use that as well, same thing. Okay, all three of these are the same equation, same explicit function. Now remember, so explicit ties this to this, this to the input to the output, whereas recursive ties output to the next output, to the next output. So the way we write that is f of x, meaning to get to this next one, we take the previous one, which we call f of x minus 1, and then what did we do to it? We added 5. Now where did we start? Well, f of 0, we had 600. That's our recursive. It has those two parts. Remember, this just stands for the next term equals the previous term. And that has to do with that idea of, oops, I didn't want to erase all of that. Saying, okay, if this is x, if 3 is x, I want to get this number. Well, to get this number, I need to drop back to 2 and know what it is. Okay, so let's keep going. You borrow $500 from a relative and you agree to pay back the debt at a rate of 15 per month. So, where do we start? Where's our 0? We started by owing 500 right at the beginning. And then every month, so this first month we paid back $15, so we're subtracting 15, right? Because we're paying it back. So our number should be getting smaller that we owe. So it would be 485 minus 15 would be 470 minus 15 would be 455, then 440, then 425. We're just subtracting 15 each time. Then 410, then 395. And if we were to go to number 8, so the explanation, we start at 500, then subtract $15 every month, or if we wanted to know what was in cell number 8, 8 times. Okay, so recursive and explicit. So that recursive, same idea. So we say, okay, we start at f of 0 equals 500. That's our starting. And what happens? Well, to get to the next term, we take the previous term and we subtract 15 from it. There's our recursive. Then our explicit, you can kind of use those same numbers. We say, okay, where did we start? Well, we started at 500. And what are we doing to 500? Subtracting 15 how many times? X amount of times, right? That's what for that minus 15 stands for, X amount of times. So if I were going to do it 8 times, we'd go 15 times 8. Because that's how many times we would have subtracted 15. And remember, multiplication is that repeated addition, the shortcut. Alright, number 9, you earn $10 per week. So, how much did we earn at 0 weeks? Well, nothing. So the first week we earned 10, then 20, then 30. So we're just adding $10 each week, right? Then 40, 50, 60, 70, and 80. So, we start at 0 and add 10 8 times to to get to that 8th cell. So recursive. So f of 0 equals 0. Then we say to get to the next term, we took that previous term and we added 10. So for our explicit function, we go y equals, well, we're adding 10 each time we add 1. So it's 10x plus 0, or just 10x, because we started at 0. Either one you can do. Alright, number 10. You are saving for a bike and can save $10 per week. You already have $25 saved. So we started out with $25. Now each week we're adding $10 to that. So kind of similar to that last one we did, right? The only difference is we didn't start at 0. We started at 25. So you can write that same thing here. Just put 25 and added 10 8 times. So we start at 25, add 10 8 times. That's how we get to that 8th cell over here. So that would be what? 65, 75, 85, 95. So our recursive, we say, well, we started at 25. And we say to get the next term, we take the previous term, we add 10 to it. For our explicit function, we say, okay, we started at 25, and we added 10 x amount of times. Alright, so now we are kind of using some sequences, finding the next 3 terms, telling us what the constant difference is, and then once again writing recursive and explicit. Now it says the first number is the first term, not the 0th. Okay, so that, if we were to make it a table, it would be starting right here. And that's very important to know. Okay, so this term is not our beginning point, a way of saying it, if we're talking about the functions. So, but what are we doing here? Looks like we're just adding 5 each time, right? So our constant difference, adding 5. So we'd get 28, 33, 38. So recursive function, well, we start, where did we start? We didn't start at 3. That's not our starting. We had to go 1 back. So we'd say f of 0 equals, well, if adding 5 is the way this is going, what? Plus 5 would give us 3. Has to be negative 2. So then I'd go, to get that next term, we took the previous term, and we added 5 to it. Now to get our explicit function, we just say, alright, f of x equals, where did we start? At negative 2. What are we doing? Adding 5. How many times? As many times as we want. Now we may want to rearrange that and make it 5x minus 2. Same thing. Whereas if you see, if we would have started and said that this was our 0 term, then it would have changed that part, and it would have changed this to be 5x plus 3, which would give you totally different y-intercepts, so you can see they would be totally different lines. So that's why it's important to understand that this first number is the first term and not the 0. Okay, let's take a look at 12 and 13, same idea. 11 to 9, 9 to 7, 7 to 5 to 3. So we're subtracting 2 each time, so it'd be 1, negative 1, negative 3. So the recursive, we start out f of 0 equals, not 11, we have to go back 1, right? Because we're thinking of this as like a table. So it'd be like 0, 1, 2, 3, 4, 5. So going backwards, that would be 13. So f of 0 equals 13, and to get the next term, we take the previous term and we subtract 2 from it. So our explicit function would be f of x equals, well, we started at 13 and then subtracted 2, so negative 2x plus 13. Because the variable always goes with the one that's the number that shows us how it changes. Okay, now number 13. We go 3 to 1.5 to 0 to negative 1.5 to negative 3. So we're actually subtracting 1.5. Or we could also think of it as going subtracting 3 over 2. That's the same thing. So we get negative 4.5 negative 6, negative 7.5. So the recursive function, now we've got to go backwards, and that 0 term would be 4.5, right? So I go f of 0 equals 4.5. Then the next term is equal to the previous term minus 1.5. Explicit function, I can go f of x equals, we started at 4.5, then subtracted 1.5 x, and we can leave it like that. I could change it to look like this. I could even say, well, that's really negative 3/2 x plus 4.5 if I wanted to. Kind of with that slope intercept, that would be easier to deal with than this. But any one of those would work. Alright, now we're just graphing some equations, kind of a little review here. So y-intercept of 5, go up to 5 on our y-axis, slope of negative 1/3, so I'm going down and to the right. So down 1 to the right 3, 1, 2, 3, down 1 to the right 3. Or I can go the exact opposite, up and to the left. So up 1 to the left 3. There's my line, and we're good. For number 2, it's in standard form, but I can change that to slope-intercept form by subtracting the 3x, giving me y equals negative 3x plus 2. Then that positive 2 is where we start. That's our y-intercept. Slope of negative 3, make it a fraction. So this time I'm going down 3 to the right 1. Down 3 to the right 1. Or I can go up 3 to the left 1. And there's my line. Okay, you could have also used the x and y intercept, where you say, well, what if I made x 0? Y would be equal to 2. It's my y-intercept. Well, then what if I made y equal to 0? So 3x equals 2, so divide by 3, and I'd have x equals 2/3, which is like 0.6, which is about right there. And get my x-intercept. And then graph the line based off that. Okay, number 3, now this is an inequality. So first we treat it like an equation and say it's slope-intercept form. So I go up to positive 4, going down 3 to the right 4. Okay, would be like right there or up 3. Something like that. Then I look and say, is it a solid or dotted? There's no equal to, so I know it's a dashed or dotted line. Then we got to decide which side to shade on. So I pick that test point. 0, 0 is my favorite. Take our inequality and put in my point. So 0 for y, 0 for x. Then that would become 0. 0 plus 4 is 4. Is 0 less than 4? Yes, that's true. So it means 0, 0 is the point that works. So we shade that side. Okay, now number 4, we're just graphing a system, right? So we graph both of these and find where they intersect. So start off, positive 4, slope is negative 5 over 1, so down 5 to the right 1. Draw my line. Second one, negative 3 to start us off with the y-intercept, then positive 2 over 1, so I'm going up 2 to the right 1, and I can see exactly where they intersect. So my answer is right here at 1, negative 1. Alright, now the last one, graphing a system of inequalities. So we graph each inequality. So negative 3, start out at negative 3, slope of 1 over 2, so up 1 to the right 2. Or I can go down 1 to the left 2. Solid or dotted? It's dotted or dashed, because there's no equal to. There's my first line. Which side do I shade? Pick the test point 0, 0. 0 for y. 0 for x. 1/2 times 0 is 0. 0 minus 3 is negative 3. Is 0 greater than negative 3? That is true. So we shade that side. Or 0, 0 is hanging out. That's the first one. Now we do the second one. Positive 2, so we go up to positive 2. Slope of negative 1 over 2, so down 2 to the right 1, or up 2 to the left 1. we see where they intersect, but it's not the intersection point that we care about. It's equal to, so we draw our solid line, pick our test point 0, 0, and test that out. 0 for y, 0 for x, then solve. Is 0 less than or equal to? That would be 0. 0 plus 2 would be 2. Is 0 less than 2? Yeah, so once again, 0, 0 is part of our solution for the blue line. Okay, so then we look to see where they are both shaded, and it's this zone right here. So that's our answer. That's the place that satisfies both of these inequalities. So that zone right there is our answer. If we look at this zone, this is just the zone that's the answer to the bottom. Over here is just the zone that's the answer to the top. Here's where there's no answer. So that's what we wanted to shade. Alright, there you guys go.